everyone. Welcome again to Ask IITians Learning. So, we were discussing about the chapter Atoms and Molecules in our last class. And we discussed about atoms, what is an atom, what is a molecule, how to find out their masses. And we also discussed about varied laws like law of conservation of mass, law of multiple proportion, etc. Do you recall that? Oh, that's wonderful if you recall. So in today's class, we are going to take the chapter to the next level or to the next topic, which is about ions and polyatomic ions. So in this particular class, we will be discussing these topics: ions, polyatomic ions, chemical formula, and how to write it. What is the significance of it? And what exactly are ions? So which is going to be our major topic today. So what are ions? Ions are charged species. What is an ion? It's a charged species. So whenever we talk about ions or the charged species, so the first thing that comes to my mind is, what exactly is a charge? What's a charge? So charge is basically if anything is having a positive or negative character. That leads to mind is that how can an atom get a positive or negative charge? And why will it get? What is the reason behind it? So when I talk about this, see, this is a sodium atom, right? If you see in this sodium, previously this was an extra electron. Now this electron was sodium lost an electron, chlorine gained an electron. Now a thing which is coming to your mind is, what is an electron? And why did it jump from sodium to chlorine? So I will be giving answers to all these questions in a while. To understand it, let's look at this model. This is basically the structure of chlorine. Now, we'll talk about a model which is known as the planetary model. Now, you know that we have a solar system, right? And in a solar system, we have sun around which all the planets move, right? Just like that, we have an atom, okay, in which there are many fundamental particles placed. Now, these fundamental particles are electrons, protons, and neutrons. These are the fundamental particles or extra particles, subatomic particles, which are present in an atom. Now, we have discussed about this. So, electron is basically a negatively charged particle. Is a chargeless species. It has zero charge. Now, what actually happens is, see, this is a part which we are going to discuss in the next chapter known as the structure of atom, where we have to discuss everything in detail, that what is an electron, what is a proton, how did it come into existence, then how does an atom look like, where are these fundamental particles placed. Okay, everything we are going to cover in the next chapter. But a basic hint is really very important in this chapter, so that you do not have to mug anything. Do you like to mug? No, I think. Right? So it's best that we understand a concept so that we can apply it easily without any hassle. Right? So for that, let's start with our planetary model. Okay? So these protons and neutrons are together known as nucleons. These are together known as nucleons. What is a nucleon? Resident of nucleus. Resident of nucleus. Now, what is nucleus? See, you remember that when I talk about electrons and protons, neutrons, we compared it with the planetary model, the solar system. In the solar system, it is the sun, which is the basic body or the heavy body around which all the planets are moving, right? So that is the major body, okay, or the central point or the reference point. Just like that, in an atom, the reference point is nucleus. That is the central point. So if you see this diagram, see this part. It is this nucleus, which is my central part. It is this nucleus which is the central part. Here, these green and blue balls are denoting protons and neutrons. And the silver balls which you can see around it, these are electrons. So what happens to electrons? They revolve around the nucleus. Now, why are they revolving? Is it like a just random number of some atoms which are revolving around the nucleus? No. There's no random number. This number rather is quite specific in nature. And that specific number is obtained by a rule which is known as 2n square rule. The rule is 2n. This rule, what is 2n square rule? As per this rule, when you talk about the energy shells or the orbits which are surrounding the nucleus, in these orbits, you can only put a restrictive number of electrons. We can only put restrictive number of electrons. So, when you talk about these rings are basically your energy shells. These rings are your energy shells or orbits. Energy shells or orbits. Now, these energy shells or orbits has some name of it. Like the first energy shell is known as the K shell. The second energy shell is known as the L shell. Third one is known as M shell, and so on. But you know that alphabets are restrictive in number. We don't have infinite number of alphabets. We only have a restrictive number, which is 26. But when we talk about these orbits are infinite. They're infinite. And only numbers can be infinite, right? So as a result, instead of using alphabets in the later classes or in your higher classes, you'll understand that they are represented by a number. Okay, the numbers are very easy to identify, isn't it? So our very first number would be 1, second, third, and so on. So as you move away from the nucleus, the number of the energy shell will increase, right? Now, these numbers are represented by a thing or a name which is known as principal quantum number. The number of the energy shells is represented by principal quantum number. Now, this quantum number is represented by small n. Small n. It is this n which we are using in our 2n square rule. Right? This n we are going to use in our 2n square. Now, what is this 2n square rule? So it talks about the number of electrons which you can put in a shell. For instance, if I talk about K shell, right? So K shell has a principal quantum number value of 1, right? So how many electrons can I put? 2 into 1 square, which is equal to 2. It means the number of electrons which I can put inside it are just 2. Same way, if I talk about L shell, the n value is 2, which means if I have to put the electrons, it will be 2 into square of 2, that is 8. So I can put 8 electrons in the second shell. Same way for M shell. Can you do the maths this time? Quickly do and tell me. You're right. When I put the n value as 3, it will be 3 square, which is 9, multiplied by 2 is 18. So I can put 18 electrons in the third shell. And I can do for the other shells also. So rest is maths. Easy. So now I hope you will be able to talk about what exactly is an atom, what are electrons, protons, neutrons, and how are they lying inside it. So now can you see how this electron is jumping from sodium to chlorine? You know that electron is negatively charged. Since it is negatively charged, if I talk about the electrons, so sodium is represented in this screen as having 11 electrons, right? Same way as you can see, chlorine is having 17 electrons. As per this way, you can see that sodium has lost 1 electron. Since electron is negatively charged, and you know that an atom is in a general notation, an atom is a neutral species, right? Atom does not have any charge. Atom is a chargeless species, which means if sodium is having 11 electrons, it is also having 11 protons in order to be neutral. This is known as atomic number, which we are going to discuss in the next topic, in the upcoming topics. So, atomic number represents how many number of protons are present in an atom. So, if I talk about sodium, it has 11 protons and 11 electrons. Now, if a sodium will lose 1 electron, so it means protons are still 11, right? But electrons will be 10, right? After the loss of 1 electron. As a result, can I just show it in this way? Proton, since we know is a positively charged species, I can write this 11 as plus. And since electrons are negatively charged species, I can write this 10 as minus. So plus 11 minus 10 will give you plus 1, which you can see here. It is this plus 1, which is the charge. And as a result, I can say that sodium has acquired positive charge. And if sodium has acquired positive charge, now I'll be calling sodium as an ion. Right? Same way if I talk about chlorine, the atomic number of chlorine is 17. So as per our discussion, what does that signify? It signifies that number of protons in chlorine will be right, 17. The number of electrons present in chlorine will be correct again, 17. Right? But since this chlorine is gaining 1 electron, right? So after the gain of 1 electron, the new number of proton, what is the new number of proton? 17 itself, because it has not gained any positive charge. The positive charge is as it is, right? But what about electrons? Correct. Since this time it has gained 1 electron, the total number of electrons now present are 18, right? As a result, can I use the same notation this time? Protons were positively charged. So can I just write positive in front of 17? So plus 17. And since electrons are negatively charged and they are 18 in numbers, so minus 18 plus 17 minus 18 will give you minus 1. See here? As a result, can I say that due to this transference of electron, chlorine has gained an electron, and because of this gaining, it acquired negative charge, right? A negative charge of minus 1. Correct? Since it acquired a charge, we can call this chlorine this time a chlorine with a negative charge. I can say that this is ion. This is not a chlorine atom anymore. This is a chloride ion now. This is an ion. Now, any charge which is positive or any ion which is positive in nature, any ion which is positive in nature is known as cation. Any ion which is positive in nature is known as cation. Whereas any ion which is negative in nature is known as anion. The ion which is negative in nature is known as anion. So, are we clear till this? Yes? Okay then. So, let's proceed towards another part which is known as valency. Let's talk about valency this time. Now, what is a valency? Valency is basically the combining capacity of an atom. Valency is the combining capacity of an atom. Now, combining capacity means that while forming a bond or while interacting with another atom, how many electrons will it gain, lose, or share? Number of electrons gained or lost or shared while interacting with another atom to form a bond. To form a bond. So, when we talk about that, so the first question that comes to our mind is, why does an atom need to interact with another atom? What is the need of it? So the need of it is to attain stability. So the reason why an atom interacts with another atom to form a bond is to attain stability. That is the question for why is it happening. Now, how does it attain stability? See, whenever we talk about anything, okay, for instance, we are normal humans, we are normal people, okay. Whenever we talk about our careers, whenever we talk about how we see ourselves in future, or what do we want to have in a future, okay, so there are few names which come to our head, right? Probably some of you might be having the name as Elon Musk, right? Some of you might be having the name as Mark Zuckerberg. Some of you might have the name as Mr. Mukesh Ambani, okay, Mr. Ratan Tata, anyone who's a big name, okay. Some of you might be good souls, might be having the names like Mother Teresa or Nelson Mandela. But then, come on, we are all greedy people. We all agree this, right? And everyone wants to be at top. Everyone wants to be rich. I want to be Mr. New, okay, I cannot be Mr. So I would like to be, or I would want to be as rich as Mr. Ambani, right? So he is my stable model. As for me, he is the stable part, okay? So if I want to be like him, I have to be on similar grounds in terms of money, right? It's very difficult to get into that, right? It's very, very difficult. So, but this is the thing. This is my reference point. To be as rich as Mr. Ambani. If I do that, yes, I'll be stable. Okay. So the same case is with the atoms. Now, they don't want to be as rich as Ambani. They want to be as rich as another species of elements which are known as noble gases. Okay. So when you talk about to attain stability, for them, the stability is noble gas like electrons. So just like we talk in terms of money, these atoms talk in terms of electrons. Okay, and their reference point is noble gases. You might have heard about the noble gases as helium, neon, argon, etc. They are noble gases. Now, what is so specific about it? The specific thing is that they have a complete valence shell. What is a valence shell? That is the valence shell is the gases have a complete outermost shell. Okay, so they have complete electrons or maximum possible electrons present in a shell. So see, this part we also call as octet rule. We call it as octet rule or duplet rule. We call it as octet rule or duplet rule. So what does that mean? It means that every atom would like to complete, every atom likes to complete their octet or duplet to attain stability. To attain stability. Okay? This is what we mean. How to use this? Let's understand that. Okay, so do you know that we need to know about the first elements? We need to know them. In this chapter, I'll be teaching you the first 10 elements. And in the next chapter, I'll be talking about the remaining 10 elements. Okay? So the first 10 elements that we are going to discuss, okay, are, with the help of a short mnemonic, a funny mnemonic. Okay? So the mnemonic is है, he, lithium, beryllium, बड़े, कामचोर, नालायक और फालतू नेता. Okay. है, he, lithium, beryllium, बड़े, कामचोर, नालायक और फालतू नेता. Now, when I talk about hai, it stands for hydrogen. Now, the way we have made these mnemonics is as per the increasing atomic order or the atomic number, which means that hydrogen is having an atomic number of 1. This is the atomic number way, and then we have the shells. So we'll talk about the K shell, L shell. Now, if I talk about the atomic number, hydrogen has the atomic number of 1, helium has the atomic number of 2, lithium has 3, beryllium has 4, boron has 5. This is their atomic number. Now, I hope you remember that whatever is the atomic number, we have the same number of protons and electrons present in it, right? It means hydrogen has only 1 electron. Where will this electron lie? In the first shell, which is K shell, right? Now, when I talk about helium, helium is having an atomic number of 2. He represents helium. H represents hydrogen. Okay. So, when I talk about helium, since it has only 2 electrons, these 2 electrons will now lie in, again, K shell, right? When I talk about lithium, lithium is having 3 electrons. So the first shell can only accommodate 2 electrons. You remember 2n square rule. As per that, the first shell can have maximum electrons as 2. So 2 electrons will come here. Now 1 electron is left. That will go to the next shell. Be stands for beryllium. Again, since it has 4 electrons, 2 electrons will go in the first shell. Now we are left with 2 more electrons. They will go in the second shell. That is the L shell. Right? Now, I talk about the next atom, which is boron, represented by B. It is having atomic number of 5. So 2 electrons will go to K shell because K shell can maximum accommodate that. How many electrons are left? 3. 3 electrons can go to L because L can have maximum of 8. Right? Same way, I'll talk about the atomic numbers. 7. Oh, my bad. It would be 6. So 6, 7, 8, 9, 10. This is your K shell, L shell, M shell, so. So C represents the next element, which is carbon. Now, since there are 6 electrons, 2 electrons I'll go to give to K shell, and then there are remaining 4 electrons, and all these 4 electrons can easily go to L, right? Next is N. N stands for nitrogen. So this nitrogen is 7. So 2 electrons will go to K. 5 electrons are remaining, which will go to L. Next atom is O. O stands for oxygen. In oxygen, we have 8 as the atomic number, which means there are 2 electrons given to K subshell. Remaining electrons are 6, which will go to L. Now we have the next element, which is F, which is fluorine. Now fluorine will have 2 electrons in the K subshell and 7 in the L. Now we have the last element in this series, which I'm going to cover today, and that is Ne, which is neon. Now in neon, 2 electrons are given to the first shell, that is K shell. Remaining electrons are 8, and all 8 can come in the L subshell, right? So if you'll see here, we talked about noble gases, right? So in the noble gases, we took an example of helium and neon, out of which we are covering 2 in this series. If you see helium, it has 2 electrons and neon is having 8 in its valence. So you remember valence shell was basically the outermost shell, right? Helium is only having 1 shell, which is the K shell. So K shell is the last shell, first and the last, and it is complete, right? Same way, if you look at neon, there are only 2 shells present, K and L, in which L is the last one, last as in which is away or which is the farthest one from the nucleus. So L is the one which is away from the nucleus or farthest from the nucleus. And if I talk L can maximum accommodate 8 electrons, and it is having 8 electrons. So it's complete. That is why we call them as stable, because they have maximum electrons which they can obtain, or which they can collect, which they can have. They're having maximum, and that is why they're quite satisfied. Since they're satisfied, we call them as stable elements. Right? I hope you all understood this, agreed with this, right? So we will be talking about chemical formula. Now, whenever we talk about chemical formula, in talking about the chemical formula, we will be talking about the valency factor. Okay. Now, in the valency factor, we need to add one more thing. Okay. And that is, how do you calculate the valency? Since we said it is the combining capacity, right? This is the combining capacity. So how do you get it from using the information of valence electrons? The electrons which are present in the valence shell are known as valence electrons. Okay? The electrons present in the valence shell are known as valence electrons. See, how to use that we'll be understanding in a while. But let's first talk about what do we mean by the term chemical formula. Chemical formula is the number and the type of atoms present in a molecule, to show the number and the type. The term which is important is number and type of atoms which are present in a molecule. And we do so by using their atomic symbols and numbers in the subscript. Okay. So basically, what does it describe? It describes that while formulating a molecule, what are the atoms used to make a molecule, and exactly how many of these atoms were used. So, isn't this a part of nature? Doesn't nature define it? Yes, indeed, nature defines it. But we have found a way or a manner in which nature does this part. So we are going to talk about this. So in order to write the chemical formula, we need to know the basic information of valency. So as I was discussing a minute ago, valence is found by knowing the valence electrons. Now, what are the valence electrons? As we have discussed, these are the outermost electrons. The outermost electrons present in a shell of an atom. So how do you find valency? See, the way is very easy. Valency is equal to the valence electrons. Valency is equal to the valence electrons if and only if the valence electrons are lying from 0 to 4. It means if the valence electron is 0, then that is the valency of that atom. If the valence electrons are 1, that becomes the valency of an atom. If the valence electrons are 4, it becomes the valency of an atom. But it is 8 continuous valence electron if valence electrons are 5 to 8. If the valence electrons are anything 5, 6, 7, 8, then you calculate the valency as 5 minus, oh, my bad. I wrote 5. Oh, no, I wrote 8. Okay, my bad. Then the valency is 8 minus valence electrons if the valence electrons are 5 to 8. Using this concept, let's see here. The valence shell is K shell and the valence electron is 1. Since it is lying in 0 to 4, its valency will be number of valence electrons. If the valence electrons are 0 to 4, since it is 1, valency is also 1. Since in helium, the valence electrons are 2, its valency is also, oh, helium is having a complete duplet, my bad, right? So this is the maximum electrons which it can have. It cannot add any more electron or lose any more. Its valency is 0. Helium is a noble gas. All noble gases have valency of 0. So you might ask, ma'am, why? Because as per the formula, it is not stating it. So the reason is because the noble gases are the most stable ones. So they are not willing to make any bond. They're not willing to lose electrons or gain electrons. Now, do you think Mr. Ambani would like to share his part of money or lose his money? Of course, he would like to gain more. Okay, but that's because he's not stable. He's not satisfied. But people who are satisfied, they are happy in their own zone. They don't want anything extra. They don't want to lose their comfort. They are happy in that very zone. Right? So helium, being a noble gas, would not like to gain electron or lose electron. He's very stable. He's very happy. Okay. Now we come to lithium. Lithium is having now the valence shell is L shell. That is the outermost one. So in the outermost, now there is only one electron. So the valency will also be 1. In beryllium, there are 2 valence electrons. So valency is 2. In boron, the valence electrons are 3. So valency is 3. In carbon, the valence electrons are 4. So valency is also 4. In nitrogen, the valence electrons are 5. So this time the valency will be 8 minus the valence electrons. Because whenever the valence electrons are from 5 to 8, valency is always 8 minus valence electrons. So 8 minus 5 is 3. For oxygen, the valence electrons are 6. So valency will be 2. For fluorine, the valence electrons are 7. So valency will be 1. And for neon, it will be 0 again. Right? I hope this part is clear to everyone. So using this, let's see an example. How to use this information. For instance, if I talk about how will sodium and chlorine combine? How will sodium and chlorine combine? Suppose someone asks you, how will sodium and chlorine combine? So first of all, what do we do? The first step is to write their symbols. Because as per the chemical formula, we try to give the information about the type of atoms and the number of atoms present in a molecule. So for the types, we try to show that with the help of their symbols. So if I want to know that in a molecule consisting of sodium and chlorine, how will it be present? So first of all, I'll write about sodium, which is represented as Na. I'll talk about chlorine, which is represented as Cl. Then what will I do? I know that the valency of sodium is 1 and that of chlorine is also 1. Now, how do I know this? I know this with that structure which I had in our second slide. Did you recall the structure which we have? See, now as per this structure, sodium is having this shell as the valence shell, the outermost one. In that outermost, there is only one electron lying. If there is one electron, what will be the valency? 1? That's right. How about chlorine? In chlorine, the outermost shell has 7 electrons. Okay, so in these 7 electrons, what will be the valency? 8 minus the valence electrons. 8 minus 7, which is 1 again. So we just tried to use the information which we already had. And using that, we'll put this part. Now what we'll do, we'll go with the second step. Second step is crisscross of valency. So first step is to write the chemical symbols of the atoms given in the question. Step 2 is crisscross their valency. Right? And now what I'll get is my chemical formula. So what is the new chemical formula? Sodium will be 1 and chlorine will be 1. So whenever there is something which is 1 and 1, we simply write it as NaCl. We don't use 1 or we don't write 1. So in your NCERTs and in your modules, there is an entire page which is devoted to these elements and their valencies. So we will be just using them for our questions and for our examples. So let's see one more example. Okay. Now, by the way, just for your information, the name of this substance is sodium chloride. The name of this substance is sodium chloride. So whenever we write the name, it is always the positive part or the metallic, we write the non-metal's name afterwards. We always write, whenever we are writing the name, we always write the metallic part first, followed by the non-metallic part. So metallic part first means the part which is cation. We always write the cationic part first, followed by anionic part. Okay. So anion is something which has a tendency to gain electrons. A negatively charged ion is your anion. So non-metals have a tendency to gain electrons. And it is because of this tendency, non-metals are also known as electronegative elements. Non-metals are also known as electronegative elements. Whereas, because of the tendency to lose electrons, electropositive elements, metals are electropositive. I hope it's clear up till here. Yes? Okay then. So now let's move to the next part. We'll see another example. So the example which I'll be taking is, let's say I have, okay. Lithium nitride. Lithium nitride. Now, as the name suggests, lithium is your lithium atom. Nitride is from nitrogen. So step one is to write the symbols which I have written. Lithium and nitrogen. After that, we write their valencies. So the valency of lithium is 1 and the valency of nitrogen is 3. So what is step 2? Step 2 is to crisscross the valency. Now, step 3 is your chemical formula after crisscrossing the valency. What you get is Li, which is 3 in number, and nitrogen, which is just 1 in number. So in short, we write it as Li3N, which is the new formula for lithium nitride. Understood? In the same way, if you see here, water is given as H2O. This is something which you know. So, do you like to find it with using this concept? Let's get that. So, if I talk about the formula of water, water is composed of the atoms as hydrogen and oxygen. So, step 1 is to write down the elements. The symbols of the elements, their valency. So I'll talk about the valency of hydrogen as 1 and the valency of oxygen is 2. And what I do is crisscross and get the chemical formula as hydrogen will be 2 and water will be 1, which I can rewrite as H2O simply. Right? That's it. Same way, I'll take one more quick example, and that is something which you have been doing for so long. Carbon dioxide, right? Carbon dioxide. So, in order to write it again, step 1 is to write the symbols carbon and oxygen. Step 2 is to write their valency and crisscrossing it. So the valency of carbon is 4 and the valency of oxygen is 2. So I'll talk about the chemical formula this time. See the glitch? The chemical formula you get is C2O4 What is this? This is not the formula which we know. So what we'll do is we'll simplify it. Whenever there is a number which can be further simplified, you know about mathematics, fractions. So you always simplify it to the lowest possible number. So 2 and 4 has a common factor of 2, right? So what we'll do is we'll divide both the atoms by 2. And as a result, to simplify it, or after simplification, what we'll get is CO2, which is definitely the formula we know, right? I hope with these examples, the things have been easier. So now let's move to the next part, which is about the polyatomic ions. What exactly is a polyatomic ion? As the name suggests, poly means many, and atomic as in atoms. So when many atoms are composed together, okay, or when many atoms are combined together to form a single molecule, when many atoms are combined together to form a single molecule, then that single molecule we call as a polyatomic molecule. Now, if that polyatomic molecule has a charge present on it, then we call that polyatomic molecule as a polyatomic ion. So a polyatomic ion means when many atoms are fused together with a charge present on it is known as a polyatomic ion. You have a list of these polyatomic ions present in your books. For example, ammonium ion, represented as NH4. So you see there is 1 nitrogen, 4 hydrogen, many atoms are present with a charge on the entire molecule. So the entire molecule acts as a single entity, as a single species. So the complete charge is present on the entire molecule. Same way, another example could be phosphate. Phosphate is made up of, again, 4 atoms, 1 phosphorus, 5 atoms, my bad, 1 phosphorus and 4 oxygens, right? With a total charge of 3 negative. So this is your phosphate ion. Okay. Another example could be sulfate ion. This sulfate ion is having 1 sulfur atom and 4 oxygen atoms with a total charge of -2. Another example could be hydroxide ion, which is having oxygen and hydrogen with a charge of -1. Now note that it is their charge which acts as its valency in the chemical formula. For polyatomic ions, charge acts as their valency in their chemical formula. I hope I have made myself clear. Yes. So in this, when we talk about this chemical formula, we are going to talk about the proportions by mass in which the different elements are combining. So for these polyatomic compounds, let's see a formula. For instance, we talk about sodium sulfate. Sodium sulfate. Now we know the step 1 is to write the symbols. So Na and SO4. Now this time I won't write the charge. We're just going to write the symbols. Right? So that is step 1. Step 2 is to write their valencies and doing the crisscross. Sodium has a valency of 1. Sulfate has a charge of -2. So we don't write plus or minus. We only write the number, the magnitude. That is the valency. Then I'll do the crisscross, and the chemical formula of sodium sulfate will turn out to be Na2SO4. Right? I hope this was easy. Yes? So let's see some questions for your practice. So in this question, you have to talk about the formulas of sodium oxide. You have to jot down these formulas. Aluminium chloride, sodium sulfide, magnesium hydroxide. For these elements like aluminium or magnesium, whose sulfide, whose valencies you do not know, you can refer your book to just know their valencies. Right? Now, I think you might have done this. Are you done practicing them? So here are the answers so that you can cross-check your answers. Now note that whenever we have anything which is a polyatomic ion, okay? In a polyatomic ion, we generally write the polyatomic part in parentheses, like sulfate. In parentheses, if the number is more than 1. If the number is more than 1. For instance, if you'll see here, so we would not be writing this hydroxide ion in parentheses had it been just 1. But since it is 2 in number, so if I simply write without parentheses, then what do you think it will refer? It will refer that hydrogen is 2 in number and not the entire OH. Therefore, this notation is a wrong way or is a wrong notation. So whenever we have ions which are more in number, more than 1 in number, we always show it inside parentheses. That's a very important fact. Let's see another subjective question. What are polyatomic ions? Give examples. This is the second type of questions which are asked in your school examinations, apart from writing down the chemical formula. So what will be the answer of this? Right. Polyatomic ions are the ions that contain more than 1 atom, but they contain a charge as a single unit or a single entity. So in polyatomic ions, there are multiple atoms which are present having a charge acting as a single entity. The charge is the overall charge in the entire molecule. For example, CO3 2 negative, which is known as your carbonate ion. It is composed of 4 atoms with a total charge of -2. So technically, it is represented as CO3 2 negative charge. Same way, H2PO4. This is a polyatomic ion with a charge of -2. Wow. Right? You can take any example in this, which are given in your books like nitrate, nitrite, sulfate, sulfite, carbonate, bicarbonate, etc. Okay? So that is all for today's class. And it was fun teaching you. So we'll meet again in our next class and we'll be talking about another concept known as the mole concept in the next class. Thank you everyone and keep learning from Ask IITians. Bye-bye.